Alright, so now I'll go through how we can solve problems involving the roots of polynomials. Alright? So have a look here. So this will be slightly different to what you're used to because you're all used to solving this first, right? And then doing stuff with it, but now we don't have to, now that we know these rules up here. So let's try this one. P plus 2, Q plus 2. Now we know that they're the roots of this quadratic, right? Okay, without solving them, this is how we can use those rules to apply them. So, first thing we need to do with this one is expand. Okay, does that make sense? Yep. Now, what you want to try to do is rearrange your equation to get P plus Q somewhere and PQ somewhere, because that's what you know the formulas for. So PQ is already here. Now, the two middle terms here, I'm going to factorize into P plus Q like that. Okay, because P plus Q, we know that there's a formula for that. Now, PQ, what's the formula for PQ? C over A. So this is going to be negative 1 over 4. Yeah? No solving required. Okay, use of the sums and products of the roots. Plus 2 outside of what's the formula for the sums? Alright, negative B over A. Plus 4. Okay? And then if we put all this together, well, let's just make everything over 4. Minus 14 plus 16, because 4 is 16 over 4. Let's try part B now. This one's not going to be so obvious, so you need to really draw on all the algebraic techniques you know, alright? So we have P squared plus Q squared. Now, by themselves, just with this right now, we can't use our two rules here. Alright, because we don't have P plus Q, and we don't have PQ, alright? So, anyone got any ideas? What can we do here? Yeah. So, if I do this, okay, so add 2PQ and then take 2PQ. That hasn't changed the equation, has it? Alright, but why did I add 2PQ? Perfect square. And now see how we have P plus Q and we have PQ? So now you can do P plus Q is negative B on A squared minus, and PQ is what? Negative 1 on 4, yep. C on A. And then what's this? 49 on 16 plus 2 on 4, which we're going to change to 8 on 16, which is 57 on 16. Alright, so be a little bit creative. Alright, think about what algebraic rules or identities you can use. And lastly, let's have a look. I said I would record this later, so I did. Let's have a look at some higher order polynomials, so past quadratics, and how we can use the formula that we learned to find the sum and the products of their roots as well. So for the time being, this is going to be pretty straightforward because we're not dealing with any complex numbers just yet until we do the unit. So let's apply the formula for the sum. So for A, alright, so the formula for the sum is negative A. So A stands for the coefficient, and N stands for the order of your polynomial. So that's the formula for the sum. Now, in this case, we want, in the case of question A, part A, we want negative a3 over a4. So what that means is the coefficient of the x cubed term over the coefficient of the x4 term. So negative 1 over 1, which is negative 1. And then for the product, well, let's use the formula. So negative 1 to the power of n times a to the power of 0 divided by a to the power of n. So in this case, we have negative 1 to the power of 4. Now a0 is our constant term, which is negative 2, over an is the coefficient of our x to the 4, which is 1, which gives us 1 times negative 2, which is negative 2. Alright, nice and simple. Let's do part B. So again, sum is going to be, write the formula, write a bit neater than me. Okay, so our highest order is 5, so a n take 1 is going to be a4, and a n is going to be a5. So that means we want negative coefficient of x to the 4, which is negative 5, and then coefficient of x to the 5 is 2, which gives us 5 on 2. Now we want the product, and this will start getting a bit straightforward now, hopefully. Formula, in this case n is 5. For the polynomial in part B, a0 is our constant, which is 8, and then an is 2. So this becomes negative 1 times 4, which is negative 4, and done. And finally, let's have a look at C, see if there's anything else to it. Alright, so this time we have a very big power, 2019, so let's see what happens here. So we've got negative a n take 1 over a n. Alright, so in this case, our subscript n take 1, well, our highest power is 2019, so n is 2019, so n take 1 is 2018. And then a n is just going to be a 2019. Now, since we don't have a 2018 term, do we? So what's the coefficient going to be? 0, you got it. And over negative 5, but that doesn't really matter anymore. The answer is going to be 0. And the product of the roots of the polynomial in part C is, write the formula. Alright, so this time n is 2019. It's an odd power, so that means negative 1 is going to stay negative. And a0 is 21, our constant, and an is negative 5. So this is basically going to be positive 21 on 5. Alright, so hopefully that's pretty straightforward for you, and I'll see you next time.